as you might know, FOB stands for free on board. Okay, so free on board means that the price excludes shipping costs. So in international trade, when buyers and sellers are negotiating contracts with each other, they have to specify the details. And free on board means that the seller will deliver the goods on the ship, up to the ship. The goods will be boarded on the ship, and once they are boarded, the goods become the responsibility of the buyer. The risk is transferred to the buyer. The buyer has to pay for the shipping costs, the insurance, and other expenses. Okay? So the seller will deliver the goods up to the shipping dock, and beyond that, it's the buyer's responsibility. Okay, so he's using data for 3 countries, the US, Germany, and Japan. They publish data on export transactions prices. And so the US data is 4 and 5 digit SITC. So SITC, it's a kind of industry trade classification, standard industry trade classification. And the more the number of digits, the narrower the product category. Okay? So it starts at industry level and then becomes more and more disaggregated. So he first compares monthly time series of US wholesale prices and German export prices for many different industries over this 7-year time period. Okay, so first set of industry price comparisons described in Figure 1, Tables 1 and 2. Exchange rate is measured in dollars per mark. So this is in the pre-Euro days. So the Deutschmark was the German currency at that time. Okay, and he constructs relative price indexes. So German mark prices multiplied by the nominal exchange rate divided by US dollar prices. So he's comparing the German price, he converts that to US dollars, divides that by the US dollar price in the US. Okay, so if the law of one price holds, then this relative price index should equal 1, right? The relative price index should equal 1 if law of one price holds. He normalizes it to 100, so it should equal 100 for the whole time period. Okay. So this is what the relative price index looks like. So he normalizes the relative price index to 100 in 1970, and you can see that if law of one price held, then you should observe a straight line. But you can see for different industries, like apparel over here, you can see that the relative price index that seems to be moving quite a lot, and does not seem to have mean reversion. There is no mean level to which it reverts back like 100. Okay? You look at paper products, you see that there are large movements, but then towards the end of the sample, it seems to be coming back towards 100. So here, there seems to be some mean reversion, but for apparel, it's really no mean reversion. 150 means a deviation of 50% from the starting point. And not just that, so he also plots the nominal exchange rate over here. So that's the dark black line. And you can see that these movements in the relative price indexes, they seem to be highly correlated with movements in the nominal exchange rate. Okay? And that should not be the case if the law of one price holds. Okay? Because when you construct the relative price index, you already take the nominal exchange rate into account. So the relative price index for each industry that's the price in Germany over the price in US, for example, and then he's multiplying that by the nominal exchange rate, and then multiplies that with 100 in 1970 to kind of normalize it, right? So the nominal exchange rate conversion has already happened when he's constructing the relative price index. Now, if law of one price holds for this particular industry, then this ratio should stay at 100 for the whole sample. Okay? It should be constant for the whole sample. But what he finds is that this ratio is very volatile. It's moving all over the place. And not just that, but movements in this relative price index are highly correlated with the nominal exchange rate. Okay? With the nominal exchange rate. Okay, so the figure presents strong evidence that relative dollar prices of apparel and paper products have not fluctuated about constant levels, but rather have been heavily influenced by the nominal exchange rate. Okay? So if you look at the figure, then it seems to indicate that the relative price of apparel is explained almost entirely by the nominal exchange rate. So apparel and the nominal exchange rate, very high correlation between them. Okay. Whereas if you look at the relative price of paper products, it is highly correlated with exchange rates in the short run, but in the long run seems to be mean reverting back to the initial level. Okay, so it's, for paper, it seems to be going back towards 100. Okay, then in tables 1 and 2, he selects 8 3-month periods during which the exchange rate was relatively stable, and then he compares movements in exchange rates and relative prices during the successive intervals between these 8 periods. Okay? And table 2 shows the cumulative changes in these variables. So let's look at these tables. Okay, so here are 8 different periods. Okay, so this is the first one. second one, and so on. Okay. Now, the first row has change in the nominal exchange rate, dollars per mark. Okay. So in this time period, nominal exchange rate changed by 4%. Okay. And if we look at the relative prices, you can see they are all generally also changing. 4%, 4.5%, 6%, 8%, in some cases more than the nominal exchange rate, like for plastic. Okay? But in general, as you see over here, there's a large change in the nominal exchange rate, and there seem to be large changes in relative prices as well. Okay? So all that is telling us, see here again, there's a large change in the nominal exchange rate, 31% in this time period, and you can see large corresponding changes in the relative price as well. So what this is telling us is that law of one price does not seem to be holding at the industry level for US and Germany. And you could do the same thing. Here he is looking at cumulative percentage changes in exchange rates and dollar prices. So this is the starting point, and you vary the ending point. Okay? So from here up to here, from here up to here, and so on. And so as you accumulate, you can see, for example, from 68 to 75, 71% change in the nominal exchange rate. That's a huge change in the nominal exchange rate. And in apparel, there is almost 80% change. So that means law of one price seems totally to fail for the apparel industry. Okay? Whereas for paper, it also fails to hold, but at least the change is not of the same magnitude as the change in the nominal exchange rate. It is much lower, okay, 36% or 30% for some of the industries. Okay, so for most of these intervals, changes in the nominal exchange rate are paralleled fairly closely by movements in 5 out of 9 relative price indexes. So for these industries, the law of one price fails to hold in a very significant way. Okay? So conclusions from this informal analysis: exchange rate movements are associated with substantial short-run changes in relative dollar price indexes for most of the categories considered here. And not just that, but in most cases, a major share of the relative price change persists for at least several years. Okay? So even over this 7-year period, even for this 7-year period, you can see substantial movements, 64%, 20%, 70%, 60% in many of the sectors. So not just that there are large deviations from the law of one price, but these deviations are quite persistent as well. Okay? So for practical purposes, his conclusion is products at this level of disaggregation are not sufficiently close substitutes to preclude large and persistent changes in relative currency prices. So after that, he wants to move. So he thinks, well, maybe we are looking at a very broad industry level, right? Within apparel, there's many different kinds of clothes. There could be men's clothes, children's clothes, women's clothes, and so on. How about if we look at a narrower, more finer level of disaggregation? Okay, so what happens then? Okay, so So he wants to go at a finer level of disaggregation than the industry groups considered above. Okay, so here, now he's using a regression analysis over here. Okay, so RT is the ratio of US import unit value by country of origin to US export unit value. So that's like the relative price variable, okay? And ST is the nominal exchange rate. Then there are some dummy variables for possible structural changes and so on. So the first hypothesis being tested, so relative price, you regress that on the nominal exchange rate and the dummy variable. And here, he's allowing for serial correlation in the error term. Okay? So in the old days, that's how the econometrics was done before the unit root and cointegration came into being. Okay? So this is in the levels, and this is in first differences. So what would you expect to find over here? If the law of one price holds, then what should we find? What is the prediction of the law of one price? So this is the relative price, the common currency relative price of different goods. If the law of one price holds, what is the key prediction that you would expect? Yeah, the relative price should be 1 or constant, and so the coefficient of the nominal exchange rate therefore should be 1. Why 1? The relative price should not be changing along with the nominal exchange rate. Okay? So the coefficient of the nominal exchange rate should be 0. Okay? It should be 0. So that's what we are trying to test. Because when we construct the relative price, we have already adjusted the foreign price for the nominal exchange rate. Once this has been done, there should be no further dependence on the nominal exchange rate if law of one price holds. Okay? So you would predict that the coefficient A1 should be insignificant. Okay? So these numbers in brackets are the t values. So you can see for A1, or if you look at Canada, these are the different goods. Is A1 significant or insignificant? Mostly it is insignificant. Okay? So that means between the US and Canada, law of one price seems to hold relatively well. For Germany, US and Germany, you can see all the T ratios are significant, with Japan mostly significant as well. So for Germany and Japan, does not seem to hold. So ratios of German to US dollar prices and Japanese to US dollar prices are significantly and positively dependent on US dollar prices of the Deutsche Mark and the Japanese yen for almost all commodity groups under consideration. Similar finding does not emerge in the Canadian case. Okay? And that may be for two reasons. One is, well, US and Canada are very close to each other, so maybe the markets are indeed more tightly integrated, and so arbitrage works better. Or it could also be because the nominal exchange rate between US and Canada was very stable during the period under consideration. The significance of the nominal exchange rate in the German and Japanese cases, however, suggests that substantial changes in exchange rates typically have substantial and persistent effects on the relative common currency prices, even for closely matched manufactured goods produced in different countries. Okay? So overall conclusion is that law of one price does not hold. That's his conclusion. Okay, so ESOD uses disaggregated data and for a number of countries providing strong empirical evidence that deviations from the law of one price are large and persistent and highly correlated with the nominal exchange rate. And then other papers find similar results to ESOD as well. Now, then there is some other work like Giovannini and these papers, and also Netter, which we are going to look at a little bit later. Okay, so this literature is about the pricing to market hypothesis, which we'll discuss in more detail later. Okay, imperfect competition kind of idea. So we're going to come back to this. Now, another interesting paper is by Engel, who uncovers a strong empirical regularity. Consumer price of a good relative to a different good within a country tends to be much less variable than the price of that good relative to a similar good in another country. What does this mean? So suppose we have two goods, let's say X and Y. Then suppose we look at this. So we have two goods, X and Y. We could look at the variance of their relative price within a country. Okay, so suppose this is the US. So we are looking at the variance of the price of, let us say, apples to oranges within the US. Or suppose here we have another country. Here we fix the good. We're looking at the same good. Price of apples in the US to the price of apples in Canada converted to US dollars. Okay? Which one do we expect to be more volatile? time, the price of two different goods within the same country, or the price of same goods across countries. So the relative price of apples to oranges within the US, or the relative price of apples in the US to apples in Canada. Which do you think should fluctuate more? What is our intuition about these? Yeah. Apples to oranges should have higher variance. So you would expect, they would expect that to be bigger than right, because these are different goods. For the same good, we expect the law of one price to hold. So we expect that the price of apples in the US, well, it should be close to the price of apples in Canada when expressed in the same currency. So this relative price, its variance should be much higher than the variance of this relative price, because you're keeping the same good. Okay? So if the law of one price holds, that's what you would expect. Okay? But what he finds in the data is that in reality, in the data, the opposite is true. Okay. So in the data, it's this does not hold. Okay? So relative price of two different goods within the same country is smaller than the relative price of the same good across countries. Okay? So that we can think of as evidence that law of one price is not working so well. Parsley and Wade look for convergence towards law of one price in the absence of trade barriers or nominal exchange rate fluctuations by analyzing 51 prices from 48 cities in the US. So they're saying, well, let's look at how the law of one price works within a country. Okay? Within a country, there is no exchange rate consideration. Okay? So the price of a car in Chicago should be the same as the price of a car in New York, and so on, in different cities in the US. So you should have convergence to law of one price, because there are no trade barriers and there are no nominal exchange rate fluctuations when you're looking within the same country. Okay? And they find convergence rates substantially higher than typically found in cross-country data. Okay? So within the same country, you do find that there is convergence to the law of one price. Okay? And that convergence is much speedier, much faster than for cross-country data. So across countries, you don't find evidence that prices will converge to the law of one price. And also the convergence occurs faster for larger price differences. Rates of convergence are slower for cities further apart. Okay? So as the cities get further and further apart, the convergence to law of one price gets slower and slower. And that's reasonable to expect. Now, extending this idea, Engel and Rogers looked at CPI data for US and Canada, and they provide evidence that the distance between cities can explain a considerable amount of price differential of similar goods in different cities of the same country. But the price differentials are considerably larger for two cities in different countries